Have you seen that trick where we flick silicone oil off a brush to produce amazing cells in an acrylic pour? You may have seen it, and I made a video about it just last week called How to Salvage Any Acrylic Pour. This technique is particularly useful if you're trying to salvage a pour or a technique that perhaps failed or didn't turn out the way you wanted. But in the experiments and in talking to people who've tried it, I realized that a lot of people have reservations about using silicone oil. Just because some people don't like the cleanup involved, other people just don't like the mess that having to spray silicone oil will create in your workspace, and that's a very valid point. So some people suggested that I use isopropyl alcohol, which I did, and I liked the results. But it got me thinking about whether you actually need a cell additive or cell activator to produce cells at all. Now, the short answer is no, you don't. Anyone who knows about this or has enough science knowledge about acrylic pouring will realize that this is a physical reaction, not a chemical reaction. Hence, the term activator in cell activator might be a little misleading. But in fact, what this phenomenon is called is the Rayleigh-Taylor instability. I'll talk about that in a separate video because that's a physics lesson and I'll need a whiteboard. But long story short, cells are a result of the Rayleigh-Taylor instability. It's a result of the dynamics of fluids. So with that being said, I'm going to run an experiment where we're going to flick 3 different fluids onto the painting. The first will be silicone oil, the second will be isopropyl alcohol, and I'll let you know what the third one is at the end of the video because I have a feeling this is what everyone will use from now on. So here we go. Here's what we're going to do in the experiment. I'm going to use 3 of these CDs. One will be for the silicone oil, one will be for the isopropyl alcohol, and one will be for our third fluid. Okay? I'm going to be using white, this cerulean blue, silver, and black. These are all mixed 2 to 1, pouring medium to the colors. But this will work in many different recipes. You don't have to do it. So I'm using varnish. You can use float roll. You can use PVA glue and water. The pouring medium doesn't really affect what we're doing. So the idea I'm going to do here is I want to spread the colors around. I'm not using a spinner. I just want to spread the colors around and then do the flick. So I'm going to start with blue, our silver, I'm going to take this, I'm going to spread it around. Bear in mind that we won't have the spinner to shake the excess off, so we'll have to drain it the manual way. Okay, that looks good. We've got some room to mix these up again, so I'm just gonna blow these lines around to get our colors nice and mixed up. And hopefully if there's excess, it falls off the side. Here's experiment number 1. This is my silicone oil. I'm gonna dab a firm brush into it. I'm gonna just add a little few drops in here, dab it, and flick. Great. Here's the brush. Here's the flick. So that will be our silicone oil. And now we're going to flick with the alcohol. Since our first brush is contaminated with silicone and I can't wash it at the moment, so I'm going to use a different one for the alcohol. And what I'm using here is isopropyl alcohol, the 99% kind. So here we go, here's the alcohol. set that aside. Now for our last one, I think this one will surprise you. And I'm just gonna grab some of the black and use it like a cell activator. So. Now the thing is, if we just apply some heat, we'll probably get some bubbles. To be honest with you, and we may see some cells right now. Ready? Here we go. Now look at that. See where we started with the swipe is a little bit thick. That's why we're not getting any cells here. But look at what's happening over here. Now let's compare them, okay? In the silicone oil experiment, we used a smaller brush than the other two. You can see lots of droplets. You can see lots of cells in what looks like lacing, right? You could almost be fooled into thinking this was a cell activator. Cool. Let's look at the second one, which is this one. So we got a few big cells. Bearing in mind we used the bigger brush that naturally had bigger droplets flung off it. It doesn't really look like lacing, but I'm gonna be honest with you, this is a result of me not flicking it properly. And now let's look at this last one. Are you ready to find out what I flicked on this? So believe it or not, it's actually just water. Here's another example, because somehow always when you give lessons, the paintings end up ugly. So here's a better example. This was just water flecked onto pour. This was just isopropyl alcohol flecked onto a pour. No cell activator, no cell additive. Do you see what I mean? So as you could see in the experiment, the cells were not really a result of the material itself that we were flicking. The same thing happened with silicone oil, as it did with isopropyl alcohol, as it did with water. And the reason behind this is what's actually happening is the force that is applied to the surface of the paint when we flick the fluid onto it, that breaks the surface tension, and what actually happens is those droplets sink and are replaced with the color underneath. Now, for people who are not familiar with the radiator instability or are relatively new, when you flick or use a cell additive and don't see colors pop up, you need to realize that cells or silicone oil doesn't magically produce a color. There has to be a layer of color underneath another layer, and what you're happening is the first one sinks and is replaced with the second one. So there you go. I hope that explanation was useful, and do let me know if you try this trick. I'd love to see your results. I'm going to leave some links for you on the screen if you're interested in learning acrylic pouring.